Today's lesson is your review for quiz 2-1. The first three problems of our quiz are going to ask you to determine if the relationships represented below are functions and to justify your answer. Remember, you can always justify your answer by using your highlighter or your pen or pencil. When we're looking at something like question number 1 and question number 2, a mapping or a table, remember, all you have to do is look for an X that is repeating. So if I look here in question number 1, I can see that this X is repeating. How do I know? I know it because this X has two arrows that are going from it, out from it. So this one is not a function. And the color that you see on the mapping would, of course, be your justification. Now, taking a look at number 2, as I notice all my X values here, they try to trick me that these two are repeating, but since one of them is negative and the other one is positive, they are not repeating. So I would say this is a function. I could show that I checked by looking at each one. I could have also done that in purple as well. You can also write down that X is not repeating if you'd like. Now on question number 3, the graph, remember you do want to do the vertical line test. The vertical line test would just be showing me that you drew a vertical line through here. Only one is necessary. I can see the movement of it, and I can see that it's only touching the graph at one spot. So this is a function. And of course, that green line on my paper would be my justification. Now, problem number 4 on your quiz today is going to look like number 4 and 5. I gave you 2 examples so that we could talk about them. Determine if the situations are functions or not. In problem number 4, it says data is collected from residents of a senior living complex on the number of vehicles the residents have owned in their lifetime and the age of the respondents. The first part of this question is giving us the situation. The second part is going to tell us what our X and Y values are. From that, we can determine if our X is going to repeat. Is the number of vehicles owned a function of the age in the situation? Now remember, when we write this sentence, the first part is going to be your Y value. So this is going to be your Y value. Remember, this can repeat all at once. Then after the a function of, this is going to be your X value. This is going to be your X value. This is the one that we want to see, does it repeat or doesn't it? So could there be multiple seniors with the same age? Yes, we don't cap it and say, oh, sorry, I have a 71-year-old, I can't take another one. So we're going to say, no, this is not a function because you can have multiple seniors of the same age. This is my X. X can't repeat is what it should say. Let me go ahead and fix that real quick. It should say X, I'm looking for where the X can repeat, and of course it can't because of the value. Okay, let's take a look at the second one. An investigator is tracking the performance of the specific portfolio over a 1-year period. The investigator records the same value in the portfolio of her spreadsheet at 8 a.m. every morning. Remember, this first sentence is just telling you the situation, what's happening, okay? This next one is going to give us our X and our Y. So let's go ahead and get ready. Is the value of the portfolio a function of the length of the investment in this situation? So my Y value would be the, my Y value would be the value of the portfolio. And if I want to, just to save time, I could just label it Y. The function of the length of the investment, and this is going to be my X. This is the one where I have to ask myself, in this situation, can this length of the investment repeat? Um, I'm going to say this length cannot repeat because the investor is putting in money at the same time. If they and only at that time. If the investor was putting in money at say 8 and then again at 9 and then again at 10, I would have multiple investments on the same day. That would not be a function. So in this case, I'm going to say yes, this is a function because the investor recorded only one portfolio function each day. So in this case, X will not repeat. Okay. All right. Questions 6 through 10, or I think it's 5 through 9 on the quiz, are going to be a question like this. You're going to be asked, you're going to be given a relation presented in one of these ways: a set of points, a graph, a mapping, a table, and you are going to be asked to fill out the other one. So in this case, I have my graph and I need to make my set of points, my table, and my mapping. Then I have to state the domain and range and state whether it is a function and explain why. Okay, remember when I'm explaining why, I'm going to go ahead and use that X cannot repeat, which I could see from any of these right here, or I could use the vertical line test because I do have the graph as well. You could use either one of those because you will have to provide a graph, even if you start with a mapping or a set of set of points or a table. All right, so to help me out here, I'm going to go ahead and I'm going to put some numbers on my graph. I'm going to go ahead and I'm going to zoom in and I'm going to put my 0, my +1, +2, +3. That looks like that's enough. I'm going to go ahead and do the same with my negatives. I'm going to also go ahead and put in my positive numbers heading in the upward direction for Y. And I'm going to do the same with my negatives for X. This is just simply going to help me put my ordered pairs in faster. All right, remember, since we read a graph from left to right, I'm going to start with that leftmost point, and it appears to be -1, +5. And I'm just going to continue to read to the left. So I started with this one. Next, I'm going to do this one. This will be my third one, and this will be my fourth and final set of points. So it looks like that middle one there is 0, 2. Remember, we're doing X, Y. So I'm always grabbing the point and going up to X and then over to Y, up to X, over to Y. So this one looks like 2, -4. It's very important that you have each of your ordered pairs put in parentheses so that I know which X goes with which Y. Don't get sloppy. And also, it's very important that I put my set of ordered pairs in a set of squiggly brackets, because then I know that these are the 4 points in this relation. I can go ahead and make a table from there. Remember, my table contains X and Y, and I'm just going to put them in the order that I wrote them down, simply because it's easier for me. Okay? And for my mapping, remember, in a mapping, you do need to have your 2 ovals. In your first oval, you are going to put your X values and you're going to put them in order from least to greatest. So they are already in order from least to greatest. There we go. If you have any repeats, let's say this one was a -1, I would not see it here. It would just go on top of the other one and there would just be one -1. My Y values, I need to be a little bit careful because they are not in order from least to greatest. It looks like I'm going to put -4, then -1, then +2, and lastly 5. And then the last thing I need to do is connect the numbers together as an ordered pair. So -1 would go to 5, 0 would go to 2, 1 would go to -1, and +2 would go to -4. Okay? All right, now I can go ahead and I can do my domain and range. Remember, your domain are your x values. Since we just have a discrete function, I'm going to list them. Oops, made a mistake. Let me make that squiggle. There we go. And I am using my mapping to get my domain and range because I've already done the work to put them in order from least to greatest over here. Here's my domain because these are my x's. Here is my range because these are my y values. So let me just go ahead and write them down. As I'm writing them down, I'm also looking, uh-oh, there we go. There we go. I'm also looking to see if this is a function. I'm going to go ahead and say, yes, this is a function. And my because could be one of two reasons. X values do not repeat. That could be one of them. I'm seeing that in number 6, number 7, and number 8. None of my X values are repeating. Or I could say because it passes the vertical line test. Sorry, that's so sloppy right there. Remember, this is an or situation. So you could either say that it is because your X values do not repeat, or you could write because it passes the vertical line test. You do not have to show both. You could even just come in here and put one vertical line. I can imagine it moving over here to this point, moving over here to this point, moving over here to that point. It doesn't have to go through each one. One is enough, and then I can visually see that you moved it. All right, our last 3 questions on our quiz today are going to ask us to state the domain and the range of the function shown on the graph. If the test does say to write a verbal description, we're going to go ahead and cross that out because once again, it's just more important to have that what it is. You might also be asked if it is continuous or discrete. I will talk about that in these last 3 examples, but I'm really going to focus on the domain and range. All right, so number 11 and number 12 are our continuous functions because they have a straight line in them. It doesn't matter if there is a 1 point or 2 points or 2 arrows or only 1 arrow. If you can see a line of any type, then it is a continuous relation. If all you see are ordered pairs, just dots, just points, like this one that we saw right here, then that would be discrete. Okay, so remember our domain are our x values, and when we start reading our x-axis, we start reading it from the left point to the right point. We always read from left to right. So we're going to go ahead and we're going to find the leftmost point, and it is right here. I need to pull that point to this axis. So I need to know what this number right here is. Well, this would be 0, and since we're going to the left from 0, we're counting -1, -2, -3, -4. So I'm going to start with -4, and I can always use this form in the middle. Okay, I can always use this form. That circle, that dot, that point at -4 is open, so I would not put a bar underneath this less than inequality. Now I'm going to go ahead and I'm going to read my graph to the right. As I read to the right side, this is the last point that I see. I notice as I circle it that it is a an arrow, not a point. This is stating that is continuing in this direction forever and ever. Since we are on the right side of our graph, this number is positive infinity. And I would go ahead and I would add this to my graph. Now, although proper, this inequality is this compound inequality, this is not the answer that we're looking for. We're looking for the answer of x and the number -4, because infinity is a concept, it's an idea. We've all agreed that the biggest number ever is positive infinity and that the smallest number ever is negative infinity. So we never really see that in a math problem when we're doing a compound inequality. What we need to decide, does positive infinity mean that we're bigger than -4 or smaller than -4? Because positive infinity is the biggest number, we are, of course, going to do greater than when we see it. So I'm going to switch that less than symbol, this one right here. I'm going to go ahead and switch it to greater than, and this would be my domain right here. All right, now I'm going to go ahead and I'm going to do the range. Remember, to do the range, we are looking at the y-axis. So when I read the y-axis, I am going to start at the bottom of my function, and I'm going to see the very lowest point that I can. It is this one right here. Notice it is an arrow. It is not a point. I am going to read the y-axis in an upwards direction until I get to the top of my function, which happens to be right here, or in this case, the top of my relation. Oh no, it is a function. Okay, so at the bottom, I see the arrow. Since we are at the bottom of our function, this is negative infinity. I can start with negative infinity. I can use my form less than y, less than, and I switched to the variable y, the letter y, because remember the range are the y values, and I don't want to use the letter x because that's the variable for domain. All right, and then I'm going to read up to the top of my function, which is this point right here. This time though, I have to head over to the y-axis because I'm doing range. This is the number that I want right here. This is my 0, since we're going to move in a downward direction. This is -1, and this would be -2. Once again, we're seeing infinity, so we cannot have that. We're going to start with the variable for range, which is the letter y. We're going to put the number, not the infinity, and now we're going to decide which symbol do we use, less than or greater than. All you have to do is look at the infinity or ask yourself, negative infinity, the smallest number ever, is it smaller than negative, or no, sorry, -2. Is it smaller than -2 or bigger than -2? If that still confuses you, just remember when you see negative infinity, you use a less than symbol. And so we're going to go ahead and keep it less than. The -2 is an open circle. The -2 at the top of my function is an open circle, so I would not add the bar. Here is my final answer for the range. All right, question number 2, same thing. I'm going to go ahead and I'm going to look at the x-axis first to do the domain. I'm going to look at the leftmost point, and it's this one right here. It's an arrow. That's infinity. This infinity, since it's on the left, would be negative infinity. And then I'm going to read my graph to the right. The right side of my graph is this point right here. It is an arrow as well, which would indicate positive infinity. Since I see an arrow, negative infinity, and positive infinity, my domain will be all real numbers. I already know my range as well because there's an arrow on both ends. The bottom's an arrow, the top's an arrow as well because there's no point on this graph, opened or closed. So the range will be also all real numbers. All right, our final function is showing from a point to a point. Okay, so I can go ahead and use the form for this one and I don't have to fix it like we did in question number 11. So I'm going to go ahead and I'm going to start with my domain by reading my x-axis. I remember I read from the left, which would be this point right here, to the right, which would be this point right here. I'm going to circle it in just a bit. Remember, I'm pulling that point that I have circled to this axis right here. So I'm going to come and pull it right down here. This is the number that I want. This one is 0. Since we're heading to the left, it would be -1. So I'm going to go ahead and I'm going to start my domain with the number -1. I am going to go ahead and use my form, less than x less than. I'm going to go ahead and make the form of my compound inequality. That circle on the left is open, so I'm going to simply leave it less than. I am not going to put the or equal to bar underneath. Now I'm going to go to the right side of my function, and it would be this point right here. I'm going to pull the point down to my x-axis. This is 0. Since I'm counting to the right, this number would be +1, 2. I'm going to go ahead and use that number right here. It is a closed circle at that point, so I'm going to go ahead and put my bar underneath because it is also equal to. All right, now we're ready to go ahead and do the domain, or sorry, to do the range. To do the range, I am going to look here at my y-axis. Remember, when you are reading the y-axis, you are going to start at the bottom of your function. This is the bottom or the lowest point of my function. And I'm going to read in an upwards direction to the top of my function, which is right here. All right, remember I am pulling that point to this line, not to the purple line because we're doing range this time. So I'm going to go ahead and pull the point over here. This is the number I want. Remember the intersection is 0, and if we're counting in an upward direction to that point, it is +1, 2, 3. So I'm going to go ahead and start with +3. I'm going to go ahead and use my compound inequality form of less than. I'm going to change the variable to y because we're talking about range and less than. Now the circle that I have here at the bottom at 3 is closed, so I'm going to go ahead and put a bar underneath. And I'm going to now go ahead and get the y value for this open circle right here. I'm pulling it over. This is the number that I want. So remember 1, 2, 3. I'm going to continue counting 4, 5, 6. So I'm going to go ahead and put the number 6. It is an open circle, so I would leave it less than. I hope this helps. Good luck on your quiz.